Hi dear folks, you see this is the Vogel initial basic feasible solution, and these are the three customers which are being provided the stock from the warehouse 1, warehouse 2, warehouse 3. Okay, so these are the cost 674,536,857. These are per unit cost, and these are the quantity which are being supplied from different warehouses to different customers. And this quantity we have found from the Vogel approximation method. So Vogel approximation method gives you the best initial basic feasible solution comparatively to northwest and least cost. So this is the solution we are having. Now, first we need to see that whether we have allocated the quantity perfectly or not as per the demand. Have we supplied as per the demand or not? So we have supplied 100 units from warehouse 1. We have supplied 180 units from warehouse 2. We have supplied 200 units from warehouse 3. That will be 480 units. Will be 480 units. So you see 480 units you will be supplying from warehouse 1, warehouse 2, warehouse 3. Now let's see what was the demand. 135, 0, 5, 130, 0, 175, 0, 175, 100, 0, 70, 170, 170, 170, 240, 170, 170, 240, 340, 170, 170, 340, and 345 we have. 345 plus 135, so 480. 480 is the answer. 175, 170 is 345. 345 plus 135 is 480. The 480 units will be was the demand. So demand and the supply are same. Now we are good to go. You need to see that what were the total allocation numbers count. 1, 2, 3, 4, 5. Because the count must be equal to this formula. You see m plus n minus 1. M is number of rows, 3. Number of column, 3. Minus 1, 5. 1, 2, 3, 4, 5. So now it means now we can apply the stepping stone method. We can also apply the Modi method, but we are applying the stepping stone method after this validation. So now you see in the first iteration, what do we have to do? In the first iteration, we have to allocate all of the we have to work upon all of the unallocated cells. So this is the first one is the X. This one is the X1, 1. Okay. First row, first column. 1, 1, first row, first column. Okay. So first row, first column, we are going to do, and how we are going to do about it? In the stepping stone method, you see in the stepping stone method, we use already allocated cells as a stepping stone to move ahead or to find the optimality. So plus 6, we are about to start with the plus 6. So where to step next? Step. We can step horizontally and vertically. Let's see horizontally what are the options. Horizontally we have gone over here. Yes, this is correct. Now from 4 where maybe where we may go to 7 only, because we have to move to allocated only 7 only. Okay, if we would move to 7, where we may move then to 8. Yes, 8 is good. And when we will arrive to 8, we have to skip 5 and we have to reach again 6. This is the best loop we have found. You see, we have taken a long route as compared to make a loop as compared to small one. For example, if there would be an allocation over here at 7, so it will be a short loop. We will prefer this one instead of that. But since there is no allocation over here, there will be no loop. So the 4 is the preferable one. Or if there was allocation over here, then we would make this loop as well. We will ignore 3 and we will make this loop as well. So what we are left with right now, plus 6 minus 4, plus 6 minus 4, plus 7, minus 8, and that's it. So we always need to find the total cost over x11 with the different stepping stones. Plus 6 minus 4 plus 2 plus 2 plus 7 plus 9 plus 9 minus 8 plus 1. So this is a positive one. You see, whenever we get the positive one, we do not have to work again on this particular cell. We are done with the x11, that is 6. Now let's move ahead towards the 7, and 7 is 1, 2, so plus 7. Okay, plus 7, what would be the options for plus 7? For from plus 7 we can move to 4, yes, but from 4 where we can move to 7, yes. And if we move to 7, where we can move to 8, yes. And when we will move to 8, you see the loop is getting bigger. Why? Because there is nothing in surrounding of 7. You see, there is nothing over here. 6 is not allocated. This 6 also not allocated. So you see, these, because of these unallocated cells, it is difficult to make a loop. So the loop of 7 would be a bigger one. So we have to start from 7, okay, and go towards 4, and then 7, then 8, then 5, then 3, then 7. So almost all of the allocated cells has to be utilized. Plus 7, minus 4, plus 7, minus 8, plus 5, minus 3, plus 7, plus 4, plus 7, minus 4, plus 7, minus 8, plus 5, minus 3. 1, 2, 3, 4, 5, 6. You see, they must always be in the even number. Plus 7 minus 4 is plus 3. Plus 3 plus 7 plus 10. Plus 10 minus 8 plus 2. Plus 2 plus 5 plus 7. Plus 7 minus 3 is plus 4. Okay. So you see, answer is in plus. So what does that shows? It shows there is no need to allocate on this cell. We are good with that. Now let's move ahead to the X23. second row, third column, starting from 6. So you see the loop is not there. Quite pretty challenging over here. You see there is no short loop. Why? Because 7 is not allocated. Okay. And over here 5 is not allocated. So what we can do, we have to move ahead. We can go to either to 4 or 7 in the vertical, but we will prefer the 7 because the second destination we have from 7. So you see we'll go to 7, 7 to 8, 8 to 5, then we'll ignore 3, then reach to 6. Why do we ignore 3? Because we can move easily to the horizontal. So there is no need to step over 3. Okay. So we can easily move. So either we can go to horizontal and vertical. So we can easily move. We do not need two stepping stones to move ahead. Plus, remember, just to validate your answer that you will be in the even. Plus 6 minus 7 plus 8 minus 5, and that's how you are done. Plus 6 minus 7 plus 8 minus 5, and ignore 3, you are done. You are back to 6. Plus 6 minus 7 minus 1 plus 8 plus 7 plus 7 minus 5 plus 2. So you see we are done with the third one as well. The last is remaining. So let's solve the last as well. Last we will solve over here. Okay. Last we will solve over here. X 3 2. So x32 is 5 plus 5. So you see, if you go to 7 in the horizontal manner, we go to 7, there is no loop over here. If you go to 8, there is a loop over here. If you go to 3, there is a loop over here. If you go to 3, then there is no loop over here, but there is a loop over here. So either you can go to 3 or you can go to 8. Both are correct. So we are starting from plus 5 minus 8 plus 5 minus 3. So you see plus 5 minus 8 minus 3 plus 5 is plus 2. Plus 2 and minus 3 is minus 1. So you see we have come up with the negative answer. Now this negative answer tells us that we need to work upon x32, and the allocation has to be changed. Okay, around it. In the same loop, the allocation has to be changed. In the same loop. Okay. The same loop was 5, 3, 5, 8. The allocation has to be changed. Okay. So this has to be done. When we will be done with this, we will do iteration number 2, just to check that is it the optimal solution or there needs to be done more. Okay, let's work upon it. So you see that was plus, starting from here, that was plus. Okay, that was minus. I took this minus. Okay, then plus, then minus. Okay, it went like this. So you see in this 130, in the minus 1, we have to look at the allocated values. 130 quantity was allocated over here, 175 quantities. Which one is the least one? 130. So we will minus 130, okay, and we will plus 130. We will plus 130 in both. Okay. Okay, let me solve for you. You see, the is first allocation we had was 5, 5, and 3. Okay, this was 8, 130, 5, that is 0. Okay, now what I'm saying is you have to reduce this allocation with 130, so this would be 0. So this would be 0. You see, that will be 0, 0. Okay, and you see this would be 45. Remaining would be 45 when we will reduce it, because these both were minus. You see, both were minus. So we have to reduce both with the least one, that is 130. So when we reduce it, the remaining would be 45. 45 is remaining. So its allocation, this allocation has become 45. Okay, this allocation is 0 now. And this allocation 5 has to be increased with the same number, that is 130. It will be 135. It was 0, it will be 135. Got it? So now we will have again a new matrix. We'll have a new matrix. Let me make for you. Six, 7, 4. Okay, 6, 7, 4. 5, 3, 6, 8, 5, 7. Okay, with the new allocation we will go. So you see, it is an old allocation. We did not have any problem with the idea of 100. 100 is good. Okay, and over here you see the new allocation. I will be writing with the blue one. New allocation is 45. Okay, new allocation is 135, and it is 0 now, so we don't add anything. Means 0. 135. Okay, so it is an old one, so I will be writing with the same marker, 70. One, two, three, 4, 5. So you see, we are done with the new allocation. After the first iteration, I'm just about to complete this, and you will move ahead. Okay, now the important one is we need to see that the demand and supply are equal or not. Very, very important. So that we shall move ahead. 100, you see, 0, 0, 100. 100. Okay. 135, 45 is 180. 70 plus 135 is 205. Okay, so it would be 100 plus 180 is 280, 280 plus 205 is 485. So 485 is the supply. Now we will be working on the demand. 135, 45 plus 135 is 180. 70 plus 100, 170. So you see, if we will add up the 135 plus 180 plus 170, it would be 485. It would be 485. So you see, our demand and supply are same. So in that context, what we have learned that whenever we had to change for the optimality, we would have to change because of the minus sign any allocation. So we need to check the supply and demand again. Remember, okay? Let me rub this for you so that we shall move on. Now we will be working upon the new iteration number 2. Iteration number 2. Okay. For the iteration number 2, you start from here. Iteration 2, x 1 1. So it's 6 plus 6. What is the loop over here? You see, there is no direct loop. Closed loop, you see. So we will be going to indirectly. So if you go to the horizontal, there is no coming back directly. So you'll go reach indirectly. When we go to vertical, we cannot reach back directly. So we have to take a long route. Plus 6 minus 4 plus 6 minus 4 plus 7, okay, plus 7 minus 5 plus 3 and minus 5. 1, 2, 3, 4, 5, 6. Remember, it has to be in even, as I already mentioned before. So we had to take the long route. Why? Because there was no short route there. So plus 6 minus 4 plus 2 plus 7 plus 9 minus 5 plus 4 plus 4 plus 3 plus 7 minus 5 is plus 2. So plus 2 is the answer. So we are good with this. X11. Let's move ahead to the X12. First row, second column. So you see, we need to get back to 7 by stepping ourselves on the allocated cells. You see, 7 to 4, yes. No, 6 is not allocated, so it will not be short one. So if we go to 7, yes, we may go to 7. And if we go to 7, we may go to 5, yes. And when we reach to 5, then we can easily reach to 7. There is no need to go to 3. There is no need to step on 3. So you see the loop is there. 7, 4, 7, 5. Plus 7, okay, plus 4. Plus 4, plus 7, plus 7, start from the plus 7, minus 4, plus 7, minus 5. Plus 7 minus 4 is plus 3, plus 3, plus 7, plus 10, plus 10, minus 5 is plus 5. So you see we have found another positive one. 6 is second row, third column. Start from the plus, you see with the plus, starting from the plus, we may go to vertically, we may go to 4 to 7, but we will not go to the 4 because there is no allocation over here. We cannot step on 7. So it's better to step on this one, 7, on 5, on 3, and get back to 6. Plus 6, minus 7, plus 5, minus 3. That's how we are done with this. Plus 6, minus 7. Plus 6, minus 7 is plus 6 minus 7 is minus 1. Plus 5 is plus 4. Minus 3 is plus 1. So we have got the positive answer. The last one we are done. We are remaining with 8. That is X, third row and first column. So plus 8. So you see, starting from the plus 8, we are lucky to just find the multiple stepping stones. 5 is allocated, so it's a stepping stone. 3 is allocated, so it's another stepping stone. 5 is allocated, it's another stepping stone. So 8, 5, 3, 5. Plus 8, minus 5, plus 3, minus 5. Plus 8, minus 5 is plus 3, plus 3, plus 3, plus 6, plus 6, minus 5 is plus 1. So you see we are done with all the remaining, and we found the positive answers. So what does it show? It is showing that we are done with the second iteration, and in the second iteration we have not found any negative index. So because of that, we are sure that this is the optimal solution. So the cost, let me take out cost for you. The cost would be starting from the customer 1. You see, this is a customer 1, customer 2, customer 3. Starting from the customer 1, 0, 135. 135 is allocated, and with quantity is 5. Sorry, cost is 5, per unit cost 5, quantity is 135. So plus customer 2, 0, quantity is 45, per unit cost is 3. Next is 135 quantity, and per unit cost is 5. Next is quantity 100. Per unit cost is 4. Next is quantity is 70, and per unit cost is 7. So you see, we just have to multiply and get the answer. So this cost will be the optimal cost to supply these 3 customers from the 3 warehouses. From these 3 warehouses, warehouse 1, warehouse 2, warehouse 3. So this will be the optimal cost, and we need to supply these quantities: 135 from warehouse 2, 45 from warehouse 2, 100 from warehouse 1, 135 from warehouse 3, 70 from warehouse 3. Thank you very much.